All right. So check your work. Here's the first two problems. Now, I skipped the solving steps, like the actual working through, like doing the two-step equation parts, but that's just because I know y'all can solve a two-step equation. So I did not feel like I had to work that part out. So if you're wondering how I got from here to here, I solved for x. Any questions on number 1 or 2? So this one, they already factored it for you. So all you had to do is set both factors equal to 0 and solve. This one was just AC method. So a times c, do your big X, and then split apart the negative 13, factor by grouping, set both factors equal to 0 and solve. So any questions on those two? All right. Here's 3 and 4. So number 3, you had to move the 12 over to the other side first. So you got one side equal to 0. Then from there was AC method. Your two factors, set them both equal to 0, solve. Number 4 was you had to factor out a GCF of -3 first, because remember you want that A value to be positive. So you had to take a negative out. Then it was AC method. Any questions on 3 or 4? All right. Number 5 and 6. So with number 5, talking about the zero product property, all it states is that if the product of two factors is equal to 0, that means that at least one of those factors has to be 0. Because remember, anything times 0 is 0. Because of that property, we can set both of our factors equal to 0, so we can find the x value or x values that if we plug it back in will at least give us one of the factors equal to 0 when we evaluate. So that's why we set both factors equal to 0 and solve at the end. Now for 6 steps for factoring, you always start by looking for that GCF. All right, because a lot of times that's usually the step that most people miss. And a lot of times if you take out that GCF first, it makes your factoring 20 times easier. For example, if we look back at number 4, that would have been some huge numbers if you didn't take that -3 out. Then, based off the number of terms, you can determine whether you use difference of squares, which is for 2 terms. So remember, difference of squares is simply if you have a squared minus b squared, so literally the difference of 2 perfect squares, it's equal to a plus b times a minus b. AC method if it's 3 terms, and then grouping if it's 4 terms. Any questions on 5 or 6? All right, then lastly, number 7. So difference between factor and solve. Solve means there is an equal sign in the problem somewhere, and we must set each factor equal to 0 at the end. And then we solve for the variable. Factor means we just use one of our above methods and we leave our answer as your 2 bubbles or as 2 factors or as a GCF and a factor, whatever it is that we use when we get factoring done. So if you see an equal sign in the problem, it's most likely a solving problem, meaning I want x equals some numbers. If it's factor, I want you to leave it as your parentheses. All right, I don't want x equals. Any questions on anything dealing with the warm-up? All right, so before we get into anything new today, I want to discuss your journal for this unit. All right, so that yellow sheet that you had to grab this morning, go ahead and have that out in front of you. So, Ms. Melby and I were discussing kind of what we want to do with the journal, and we decided that we're going to kind of give you guys a bit more free reign. All right. So, with you guys being honor students, it should be at some point we can take the leash off and let you guys have at it. Not saying that there's still not going to be guidelines, but it'll be a little bit more open ended. All right. So, we're kind of away from copying. Okay. So, what we're doing for journals. When I was at my very first year teaching, I was at Jacksonville High School. And something we did a lot was called one-pagers. Right? Has anyone ever heard of them? All right. So essentially what a one-pager is that it's just kind of a summation of a topic, and it's just all fits on one sheet of paper. All right. Now, essentially, for every lesson in this unit, you're going to be making a one-pager. All right. Now, we did group together units like lessons that talk about the same thing. So, for example, 4.3 to 4.5 is all factoring, so that's just all going to be one-pager. All right. Now, your guidelines are here. Okay. So, in the box, those are the general directions. So, what it says is that for these series of one-pagers, it covers the topics and will include steps and worked out examples. Now, here's the thing, guys. So a lot of you with your last journal, you lost some credit because you didn't include everything. You must include everything on this paper in order to receive full credit. If you don't, I'm taking off points. Okay? So it's right there, underlined, big letters, bold. You gotta include everything. You cannot skim. It's also got to be neat and easy to follow. If I can't read it, it's not happening. I can read some pretty bad handwriting, guys. But if it's like complete chicken scratch, you got to at least have some neatness to it. Now, if you want to include color in it, it's fine. It's optional. I'm not going to dock you if you don't have color in it. But it's highly encouraged just because, maybe easier to read. Or maybe easier for you to follow. Because remember, at the end of the day, your journal is going to be used as a reference for you guys. So when you go on to Math 3, you have something that you can look back on to help you remember what we talked about in Math 2. Because trust me, Math 3, a lot of the stuff in Math 2 is going to come back to haunt you, but it's going to be worse. All right? It's going to be harder. So, now, with these one-pagers, you have an option. So you can either create the one-pagers within your journal, so just in the pages of your journal, or you can do it on a separate sheet of paper and glue it in. Now, the first two one-pagers, so number 1, the 4.1 to 4.2, all right? Oh, one last thing. So, any examples can come from the following resources. So all your one-pagers are going to include some type of examples. You can either get them from your packet that we worked out in class, or we didn't do, and you want to work them out, or from your homework assignments. All right. You can also use examples you found on the internet, or you can use examples generated from AI, or by using Gemini. So you got a couple of different options. The only thing is you're responsible for making the work is correct, and that the work follows what we learned in class. All right. So, for example, if you use the AI option, make sure that the work actually follows the method that we did. Okay? Because sometimes it doesn't. All right. So, 4.1, 4.2, this one-pager I will be providing for you. All right. So, it states kind of what is going to be on it, but this is one I'm going to physically give to you to glue in. All right, that's going to kind of be your reference. All right, but it's going to include steps for simplifying radicals and radical operations, and simplifying imaginary numbers, as well as an example of each. Then 4.3 to 4.5, factoring and solving by factoring. This one we're going to do together in class today. All right, that's why I passed around that big sheet of paper. We're going to do it in class together today. All right. So this is going to include steps for how to factor using all the different methods that we talked about, which are listed there. At least one example for each method listed. Steps for how to solve a quadratic by factoring, including an explanation on the zero product property. At least one example of solving by factoring for the following factoring methods. So all the methods I listed right there. All right. Now, I say at least one example for each of the methods. You can add more to it if you want. All right. You don't have to. You just have to have at least one per topic, but you can add more if you want. Now, the last three, so the ones on the back of the paper, those are for you to do. All right. So those three are the ones that you should be doing on your own. That'll be due by the day of the test. So you have at least a week. All right. Now, these three are actually pretty short, all things considering, because those lessons aren't that long. So we're going to do pretty much the long ones together. All right. Now, 4.6, that's the lesson we're going to go over today after we go through the one pager, because again, that lesson's really quick. We're going to talk about the standard form of a quadratic function and how to put it in standard form. So you're going to state what that is and how you put things in standard form. That's a review from the last unit. An example of putting a quadratic in standard form, and an example. So an example of putting a quadratic function in a standard form, and an example of putting a quadratic equation in standard form. Now, who knows the difference between a function and an equation? Say again? Kind of. So one of them does have an equal sign. But the biggest thing is that typically you see a function as f of x or y equals. A equation, you see it equal to some number or some other expression. All right, that's the difference. Then you're going to have the formula for the discriminant. So we're going to learn that today. A description of what the discriminant tells us about the solutions. Again, we're going to talk about that today. And an example of finding the discriminant for each type of answer. All right. And then the other two, you can read those on your own, but those will cover the other lessons that we're going through this week. All right. Now, as of right now, I'm thinking that this will be due the day of the test, but I'll look into it. So kind of plan for that right now, but I may say like maybe the day after the test or the next day after the test or whatever. All right, I'll figure that out. But right now, expect that it's going to be the day of the test that's due. Okay. Now, any questions on what I expect from you guys? And again, we're going to do an example in class today. So you have something to kind of, gauge what I'm looking for. And then I'll give you another example tomorrow, which is just the one that you're just going to flat out paste in. All right. Now you're still responsible for your vocabulary. You're still responsible for your I can statements on each of these. All right. But this kind of gives you a little bit more autonomy. And again, in reality, it's basically just recopying your notes almost, but not to the same extent your notes are. All right. Okay, so we're going to go ahead and go through. So we're going to go ahead and go through the factoring one pager together. You can either put it on them or you can put it beside them. It doesn't matter. Yeah. All right, so take out that sheet of paper that I had you guys grab. Also, if you want anything color-wise, you don't have to, but if you want anything color-wise, I got colored pencils on the shelf, so if you want to grab a couple. If you want to take out some, that's up to you. I'll give you a minute to do that. Now, again, you can make this as fancy or as simple as you want. You can make it as colorful as you want, or it can just be in straight pencil. The only thing is that you've got to make it easy to follow, so I know kind of where everything is. I don't have to be kind of figuring out, okay, what are they doing here? Oh, come on. All right. So, again, everyone should have that blank sheet of paper out. We're literally doing this together. I would do this on the long edge. So, in other words, turn it so that it's horizontal. All right. So, I would say always start by your title. So, whatever is listed in bold for the directions, that's what I would put as your title. So, I would put 4.3 to 4.5, factoring, and solving by factoring. And again, you don't have to make it exactly like mine. You can add your own flair to it, but this is just kind of an example of what I expect. Now, because this is kind of 2-in-1, I would actually break your paper in half. So I would draw a line down the middle so that you're going to have factoring on one side, solving on the other side. And again, it doesn't have to be perfect. So I'm going to put factoring over here. Now, since factoring, it wants it in steps and then an example of each. That's what I'm going to do. So I'm going to put steps over here. And then an example over here. Now, you may want your packet out just so you have, just so you can like copy easily where I'm going to be taking from. So the first thing I'm going to be taking from is on page 1 of your packet. So first method I'm going through is GCF. So the steps are at the very top of page 1 for GCF. So I have look at all terms and determine the GCF. I'll make a note that that's the greatest common factor. Second step, write the GCF. And guys, I'm literally just copying what's on page 1 of your packet. So if you can't read it on mine, just look at yours. And then divide the GCF out of each term and put the quotient inside of the parentheses. Now, on the other side, I'm going to do a GCF example. And I'm going to do example 4, still on page 1. All right. So I'm just going to rewrite the example. So the example I want is 24 m. I'm not going to write the word example. Let's do 24 m squared n p squared plus 36 m squared n squared p minus 54 m squared n cubed p cubed. Now, I believe we already worked that example out together, correct? All right, so you're literally just going to copy the work you did for it. All right. So I would then put my GCF is 6 m squared n and then p. So that's what I would divide into all of these. And then my answer would be my original GCF. And then what I get when I divided. So that'll be 4p plus 6n minus 9 n squared p squared. Any questions on what I did? All right. So now we're going to do GCF. So I'm going to draw a line just so I know that that's where the separation is. And guys, you're going to need to write small because these are, if you screwed up, just you can do some more work on the back, but you need to write small because there's a lot of information going on here. So this next one we're talking about is grouping. Now, I'm going to make a note that this is when we have 4 terms. That's when we want to group. So the steps is split problem into 2 pairs. So again, I'm just copying the notes that are still on page 1. Take the GCF out of each pair. The parentheses will match. So I would highlight that. They need to match. And then pull this out of the problem like a common factor. And lastly, your answer should be the product of 2 binomials. Now I'm going to do an example. So I'm going to do example 6 on page 1. So I'm just going to copy it. I'm going to draw my lines. GCF of the first is 2a squared. So that'll leave me with 2a plus 5. GCF of the second is negative 3. So that'll be 2a plus 5. Since my parentheses match, I'm just going to make a note that my GCF is 2a plus 5, which that's what I'm going to pull out. So I divide both of these by 2a plus 5, 2a plus 5. So these cancel. So my answer is 2a plus 5 times 2a squared minus 3. So guys, are you starting to understand kind of what I'm looking for here? Now, if you don't like the way like you're doing it now, you can always redo it. I'll post this. And I have more paper if you want it. All right, now we're going to do AC methods. So I'm looking at page 5 of your packet. So I'm doing AC method. I'm just going to make notes for both A equal to 1 and A is greater than 1. I'm also going to make a note that this is also for 3 terms. So the steps. Look for a GCF of all terms. Two, List all factors of A times C and their sums find a pair of factors that adds to B. I'm also making a note here that I can also do this as big X. So if I wanted to do big X, I have A times C up top, B on the bottom, and then my two numbers that multiplied A times C add to give me B. So again, you can either do it as a table of listing the factors, or you can do it as big X, whichever you like. Then I'm going to split the middle term into the factors that add to B. And I'm going to factor by grouping. Now, since I want an example for when A is equal to 1 and when A is not equal to 1, we're going to do two different examples here. So I'm just going to do examples A and B that's still listed on page 5. So the first one is the AC method when A is equal to 1. So that's x squared plus 9x plus 20. Off to the side, I'm going to do a big X. So my A times C is 20. My B is 9. Now, you can list the list of factors if you want. You don't necessarily have to, because you guys should be fairly decent at this by now. But I'm going to skip the list. Again, you can add it if you want to, but you don't have to. So factors of 20 that add to 9 are 4 and 5. So I want to use that to break apart my 9x. So then I have x squared plus 4x plus 5x plus 20. And then we solve by grouping. So x times x plus 4 plus 5 times x plus 4. So if I take out my GCF of x plus 4, this would be x plus 4 with an x plus 5 left over. Now, that was when my a value was equal to 1. If my a value was greater than 1, so AC method, a is greater than 1, so I'm doing example B now, so x squared plus 5x plus 3. I'm going to do my big X off to the side. So I have a times c, which is 6, 5. So that'll be 3 and 2. This will be 2x squared plus 3x plus 2x plus 3. And factor by grouping. So x, 2x plus 3, plus 1, 2x plus 3. So this would be 2x plus 3 times x plus 1. So guys, the factoring side will be longer, but the solving side will be shorter because honestly the steps, it's a one shot. You don't have to keep writing them. All right, we're almost done with the factoring side. All right. So difference of squares. That's the next one. So this is the one that you guys did with Miss Melby yesterday. All right. So if you didn't really understand yesterday, this is kind of a good review. So difference of squares. I'm going to put DOS as well as two terms. Now, these steps are short. So first off, we got to recognize if we have a difference of squares, because it'll be in the form a perfect square minus a perfect square. So a squared minus b squared. So this is the form that it'll be in to start. All right. Now, these squares I'm coming up with kind of on my own because on page 11 is where I'm looking at. There's not really a nice set of steps listed. So these steps I can kind of come up with on my own. All right. So 2. If it's a difference of squares, find A and B by taking the square root of A squared and B squared. Then put A and B in the form A plus B times A minus B. And then it's factored. Now, the last thing I would say is check to see if there is any more difference of squares, because it does happen occasionally. If so, factor again. Now, step 4 rarely happens, but it does happen where your answer is actually there. One of the factors is a difference of squares, so you'd have to factor it again. All right, so my difference of squares example. I'm gonna do example 2. So on page 11, example 2. So that example is 4t squared minus 25. So first off, I'm going to take note that 4t squared is a perfect square. And 25 is a perfect square. Thus, and we're subtracting, so we have a difference of squares. Now, a squared is equal to 4t squared. B squared is equal to 25. You don't need to worry about that minus. So it's not negative 25, it's just 25. All right, the minus is just telling us it's actually a difference of squares. I'm going to take the square root of them to get my a and b values. So a is equal to 2t. Square root of 4 is 2. Square root of t squared is t. And b is 5. Now, guys, a little trick for variables is that it's a perfect square variable-wise if the exponent is even. So the exponent is even, it's a perfect square. And all you'd have to do to get the square root is just divide it by 2. And that's your new exponent. So for example, if it was t to the fourth, the square root of t to the fourth is t squared. Now I'm going to put in the form of a plus b, so 2t plus 5 times 2t minus 5. And since 2 and 5 or t is not perfect squares, I'm done. All right. Put A and B in the form and then check CDOS. All right, any questions on difference of squares? Because I know that's the stuff you covered Friday without me. All right, we're almost done. 2 more, at least for the factoring. Again, solving is going to be easy because we just have one set of steps and then just a couple examples. All right, so then we got a perfect square trinomial. So your first step. And again, guys, if you don't get this all right now, it's okay. I'm going to post this later. So you recognize if you have a perfect square trinomial, use the back. Well, okay, so just keep putting to the side. So use the other side because solving won't take as much space. All right, so recognize if you have a perfect square trinomial, which would be in the form a squared plus or minus 2ab plus b squared. So if it's a perfect square trinomial, it would be a squared plus or minus whatever twice the product of a times b is plus b squared. So notice how the last term always has a plus in front of it. If it's a minus, it's automatically not a perfect square trinomial if the last term has a minus in front of it. Then find the square root of a squared and b squared. And identify the sign of the second term. And then put in the form a plus or minus b squared where a is the square root of a squared, b is the square root of b squared, and this is the sine of the second term. So we talked about this, guys, when we did completing the square in the last unit. Now, I would make a note here of you can factor using the AC method. But make sure it is in the above form. So for example, if you had x plus 1 times x plus 1, if you factored using AC method, just make sure you write it as x plus 1 squared. All right, an example, I'm going to use example 7 on page 12. So I have 4x squared plus 12x plus 9. All right. So I'm going to take the square root of the first and second, keep the sign of the second. So a squared is equal to 4x squared. So a is equal to 2x. B squared is equal to 9. So b is equal to 3. And then the sign of the second term is that plus. So if I write it in the form, this will be 2x plus 3 all squared. So again, we did this a lot, guys, when we did completing the square. So this one should be really familiar to you. What's up? No. So guys, I'm referring to this form. All right, last one, then we're done with factoring. So guys, to save some time with the solving side, what I think I'm going to do is I'm going to write out the steps for you, and then I'm going to tell you which examples to pull for you to copy. All right, so there'll be ones that we already did. So I'm not going to work them out already because you should already have them worked out in your notes. All right. So the steps for multi-step, I'm pulling from page 13. So first, take out a GCF. Then, if you have two terms, difference of squares, three terms, AC method, four terms, grouping. So with multi-step factoring, you guys just have to determine which method you'd have to use based off the number of terms. So it's kind of like that flow chart that I gave you guys last week when I was giving the pre-ACT, where you guys, it had it told you where to go after your GCF stuff. That's what I mean. And your last step, look again for any more factoring. All right, so the example I want to do is example 16. So it's x squared, not x squared, x to the 32 power minus 1. So there's no GCF, and there's two terms, which means difference of squares. So I'm going to take the square root of both, because they are difference of squares. This would be a is equal to x to the 16th, b is equal to 1. So remember, taking the square root of any even exponent, you just divide it by 2. Then I'm going to put in the form a plus b, a minus b, so this be x to the 16th plus 1, x to the 16th minus 1. However, guys, are we done? What do you guys notice about right here? We got another difference of squares, so we got to factor that again. So, square root that. A is now x to the 8th. B is now 1. So I'm going to bring down the x to the 16th plus 1. And then do x to the 8th plus 1. X to the 8th minus 1. But am I done again? Nope. Got another difference of squares. So again, square root the first and the last. So a is equal to x to the 4th. B is equal to 1. So this would be x to the 16th plus 1. X to the 8th plus 1. Remember to bring down all of your old factors. This will be x to the 4th plus 1 times x to the 4th minus 1. Still not done. So we got another difference of squares. Square root the first and the last. A is equal to x squared. B is equal to 1. So x to the 16th plus 1 times x to the 8th plus 1 times x to the 4th plus 1 times x squared plus 1 times x squared minus 1. I promise this is the last time we're going to have to do another difference of squares. So square root first and last. A is equal to x. B is equal to 1. So it's x to the 16th plus 1, x to the 8th plus 1, x to the 4th plus 1, x squared plus 1, x plus 1, x minus 1. And we're finally done. So guys, I did that example specifically because That's what a lot of people tend to miss. They tend to miss those extra difference of squares that pop up after you factor. So you have to factor until there's absolutely no difference of squares. All right. So we're finally done with factoring. So now let's move on to solving. Now, again, solving is going to be really, really quick because I'm not actually going to write out all the examples. What I am going to do, however, is tell you where in your packet to get the examples from. All right, so I'm going to leave those examples up to you. So this one I'm not going to divide, but we're just going to do steps first. So these steps I'm going to take from page 12 because we're right there. So the first step is put all terms on one side of the equal sign in descending order. We then factor completely. And then set each factor equal to 0 and solve. Now, it asked me to also state what the zero product property is. So I'm just going to state that off to the side. And all the zero product property is if the product of two factors is 0, then at least one of the factors is equal to 0. Now, I don't ask you to do as nearly as many examples as factoring. So you should have one for GCF. You should have one for AC method, where A is equal to 1. You should have one for AC method when A is greater than 1. You should have one for difference of squares. And you should have a multi-step. So I'm going to write down the example and I'm going to tell you which page I got it from, and then you'll just have to write out the work later. All right. So for GCF, I'm going to do this example. So 4x squared minus 5. Oops. 4x squared is equal to negative 5x. And this is on page 2, and it's number 10 of your packet. So again, you got to go back and put in the work later. AC method when A is equal to 1. The one I'm going to do is x squared minus 7x plus 12 is equal to 0. And this is page 7, letter A or number A, whatever you want to say. I don't care. So when A is greater than 1, I'm going to do same page. 3x squared minus 17x is equal to negative 20. Still page 7, but it's letter F. Now, I don't know specifically which ones you did with Miss Melby, but I will personally go back and work these out later. So I'll post that on the journal page as well as in your notes page in Canvas. But for DOS, I'm going to do 49x squared minus 36 equal to 0. So this is page 14, number 9. That's what I'm saying. I'm going to write it in later. And then I'm going to take from the warm-up that we did this morning for the last one. So for the last one, I'm going to do negative 9k squared minus 66k minus 21 is equal to 0. So I took this from page 16, number 4. All right, so that work you guys can go back and write on your own, or I'll do the work later today for you guys and I'll post it. All right, so any questions on what to expect from your one-pagers? Now, this was probably the biggest one that you would have had it done. The other ones are not as bad, they're not as long. So I do typically want you guys to fit it all on one-pager, and then you're going to staple it in your notebook in the order that's on your yellow paper. All right, so this will be the second one. I'll give you the square root one tomorrow. Yes. You fold it, and then you staple it. Yes. I will, yes. All right. Now, put that away for right now. Quickly, we're just going to go through the notes for today because they're really short. All right. So in your packet, go ahead and turn to page 19. So on page 19 of your packet. Yeah. Do I need to pass? Grab a blue pass from under my other podium and I'll write you one. Okay. So now, part of lesson 4.6 is the whole simplifying radicals. However, we already did a bunch of that already. The new part that we do need to know, just take the bathroom pass, honestly. The new part we need to know is the discriminant. Now, remember, your standard form of a quadratic is ax squared plus bx plus c. Now, the discriminant is really, really easy to find. I'll explain what the discriminant is in a second. But for right now, the discriminant is just a number that we find in the quadratic formula. And all the discriminant tells us is the number and the type of solutions that we have. So the formula for it is b squared minus 4ac. Now, what the discriminant tells us is it tells us the number of solutions that we will have as well as the type. And remember, by type, I mean whether it's real or imaginary. Now, for whatever reason, this is not written in your notes, so I would write this off to the side or somewhere where you can fit it. But for your discriminant, if you get a positive number, that means you have two real solutions. If you get 0, that means you have one real solution. And if you get a negative number, you have two imaginary solutions, so they contain an I. So again, that is the discriminant answers. Now, the discriminant does not tell you what the solution actually is. So whatever you get for the discriminant is not actually the solution. It's just a way that we can tell how many solutions we're going to end up with and the type. So whether they're going to be real or imaginary. All right. So just like we did, all right. So just like with factoring, you want to get both sides equal to 0 before you take the discriminant. All right. Now, I always like to label A, B, C first, just so I know what I'm talking about. And then we're just going to put into the formula b squared minus 4ac. So someone raise their hand and tell me what I'm going to plug in for b. 5. So we have 5 squared minus 4 times what? What's A? What's C? 2. And then we just evaluate. This would be 25 minus, what's 4 times 1? Guys, what's 4 times 1? 4 times 2? 8. So then what's 25 minus 8? 17. So our discriminant is 17. Now, based off of our discriminant, how many solutions do you think we're going to have and what type? 2 real solutions. So because it's a positive number, we're going to have 2 real solutions. Now, again, the discriminant is not an actual solution. It's just telling us the type that we're going to have. The number of solutions and the type we're going to have. All right, let's try another one. First off, I need to get one side equal to 0, so what do I need to do? Subtract the 8n to both sides. This would be negative 7n squared plus 8n. Now, if there's no constant, but we still need that c value, what will we put in that place? Nope. So if there's no constant, but we still need a c value, 0. If you're trying to put a placeholder for nothing, you put 0. All right? So this will be your A, B, and C. So I would have 8 squared, some B squared, minus 4 times negative 7 times 0. So what's 8 squared, guys? 64. What's negative 4 times negative 7? Positive 28 times 0? 0. So this would be plus 0. So what's my discriminant? 64. So based off of my discriminant, how many solutions and what type do you think I want to have? 2 real solutions. It's B squared. So when you subtracted the 8n over to the other side, 16n minus 8n is positive 8n. The minus what? The minus 4ac, that's just part of the formula. Oh, the minus 7 is your A value. So guys, I'm literally using these numbers as A, B, and C. So if you want, you can also list them off to the side. So A is equal to negative 7, B is equal to 8, C is equal to 0. All right. All right. So walk me through the next one. Raise your hand. Tell me what to do first. So remember, I need one side equal to 0 first. So Claire, what do I do? Right. So I'm going to add 7x and add the 9x. Now, since the 7x has nothing to combine with, we're just going to put it in the middle. So we got negative 6x squared plus 7x. And then what's negative 6 plus 9? Positive 3. Now, I'm going to go ahead and list out my A, B, and C. So what's my A value? Anyone? Negative 6. What's my B? What's my C? 3. And again, I'm getting those because I'm looking at my standard form of a quadratic, which is ax squared plus bx plus c. So the a is always next to the x squared, the b is always next to the x, and the c is always the constant. So if I put this into my discriminant formula, which is b squared minus 4ac, how would I set it up? 7 squared minus 4 times. Good. So what's 7 squared? Yep. What's negative 4 times negative 6? Positive 24. And then what's positive 24 times 3? 72. So plus 72. So what's 49 plus 72? So 121. So our discriminant's positive. So what type of solution do I have? 2 real solutions. All right. Do I need to do the last discriminant example? All right. Now, the last little bit of the notes is just reviewing simplifying radicals, which we did at the beginning of the unit. Does anyone need me to do an example with simplifying the radical, rationalizing the denominator, any of that? Because we already did that in 4.1, 4.2. Are you guys good with that stuff? So if you need to reference it, it's going to be in your packet from like the very first packet that we got. Okay, so your homework for tonight is just going to be a delta math. All right. Now, I would like you to show your work on page 21. So page 21 in your packet, I do want you to show your work for that Delta math there. All right. And that's what I will be checking. So I'm going to check your homework from Friday. Yes. All Delta maths are graded. Yep. So I'm going to check page 15, which was the homework from Friday. At least that's what Miss Melby told me she assigned you. That's why I'm giving it to you today as well. All right. Because I didn't know if y'all knew that or not. And then I'm also going to check the homework from Thursday that we had tomorrow. Homework from Thursday I think it was pages 8 and 9. Yeah, 8 and 9. And guys, I will post the one pager in both the that we did today in both the journal page on Canvas as well as the note page on Canvas. So if you missed something from it, feel free to copy that. And again, at any point, so again, I would not wait till the last minute to do these journals. Basically, my recommendation is as soon as we get through a lesson, do it again. All right. So at any point, if you have questions on it, please come see me. I will gladly answer them because I've done my fair share of one pagers. All right. And again, you don't have to make it exactly like we did the factoring one. There's plenty of freedom there as long as you include those guidelines. So if you want to do like maybe a web or any other type of graphic organizer type method to make the one pager, it's up to you. There's a lot of freedom with that. You just got to make sure you include everything that's listed on that yellow sheet. All right, so you only got about 3 minutes left of class.